Hello friends, so welcome back to my channel. In today's session we'll discuss about SR flip-flop. What is SR flip-flop? It is an electronic component which is used to store one single bit of information. So it just saves one bit of information. Here we are having the truth table of SR flip-flop in Simulink. So before going through this truth table, we'll discuss how SR flip-flop looks like. So here I'm having SR flip-flop. You can check SR flip-flop in Simulink extras and flip-flops, and you can drag SR flip-flop here. Double click on it and you can set the initial condition for this flip-flop. So this flip-flop is having two input ports and two output ports. The S stands for set, the R stands for reset, Q is the output, and Q's complement is another output. So here I have connected the scope for ease of understanding. So let's consider the truth table of SR flip-flop. So when set is 0 and reset is 0, then Q and Q's complement will be the memory. Means it will show the last output. When set is set to 1 and reset is 0, then Q will set to 1 and Q's complement will set to 0. At this stage, we are having the value of Q as a 1. So when in next step, we'll set S to 0 and R to 0, then we can see the memory, means we'll see Q as a 1 and Q's complement as a 0. Then when reset is set to 1, the Q will set to 0 and Q's complement will set to 1. And when both S and R is set to 1, then basically it is an invalid condition, but in Simulink you can see the Q and Q's complement will set to 0. So let's check this logic in MATLAB Simulink. We'll move step by step. At initial stage, both set and reset are 0, so you can see the output as a memory. So it is showing the previous value, that is, but obviously it's a 0 and Q's complement as a 1. Now I will set S to 1 and you can see the S is set to 1 and output is set to 1. Right. If S is set to 0, you can see output will remain 1. So it is showing the previous value as it is stored in a memory. 1 bit data is stored in a memory. Now when reset is set to 1, you can see the Q drops to 0 and Q's complement rises to 1. So when reset is set to 1, the Q will drop to 0 and Q's complement will set to 1. Again, if reset is set to 0, then it will show the output as a memory. Here, here you can see the output as a memory. Again, I will set S to 1. You can see S is set to 1, the Q is set to 1, and Q's complement is set to 0. Now I will set reset to 1, and you can see when reset is set to 1, the Q drops to 0. So this is how truth table for SR flip-flop works. So that's it for today. Thank you guys. Please like, share and subscribe my channel. Thank you.